Hi, welcome back to our channel and back to the tutorial for computer organization. And today we want to discuss the part 3, that is the types of hazard, control hazard. The previous video I explained about the types of hazard like structure and data hazard also. Let's see today what is control hazard with simple example. So before going that, we had know what is exactly the meaning of control hazard. The other name of control hazard called as a branch hazard here. On many instruction pipeline microarchitectures, the process will not know the outcome of the branch when it needs to be insert a new instruction into the pipeline. That is generally the first stage. So this is the meaning. That means what? On many instruction pipeline is there. There will be a process. The process don't know the outcome of the branch, or you can say with example, we get more clarity here. That means whenever try to execute the instructions, we don't know the whenever start to execute and fetch instruction, we don't know the outcome. That is the meaning here. Just assume that there will be instruction like S1, S2 followed by S6 and so on. Here during the first clock pulse, what happen means we fetch the S1 and we fetch the S1 normally. Then in the second phase, we can fetch ID phase of S1 and go for another one. Similarly, in third clock pulse, you can fetch S3 and start ID of S1 also here. And here already S1, there will be if condition is there. So we have to check whether the condition is true or not. If at all false, there will be issue. If at all true, not issue. So like that, we can go for everything. So we can initially start with fetch S1 and clock pulse is 2, we can fetch S2 as well as the ID of fetch ID of S1 also. And here, the next phase, what we can do, we can fetch S4 here, as seen in the diagram. Then as seen in the instruction flow here. And there will be 4 stages. Okay, instruction fetch, instruction decode, execution, and write back the result. So here, after in the interface, what we are doing, we can fetch the S4 and we can start ID phase of S3 also. See here, both you can do. So we can fetch S4 as well as we can start ID phase of S3 and we can start execution of S2 also. That is possible. And here the problem is what? That is, we can understand here there will be S3 and S4. Again S3 is there. These are marked in a red color because these are the wastage of pipeline as this was never required. That means what? We are going to execute it. Even the executing, there is no use of executing these instructions here. That means what? That is the clock cycles are the 3 clock cycles wasted. That is out of 6 here. And here you have to remember, if at all condition false, see, we are in the clock cycle 4, we can execute S1 and check the condition. If the test condition false, what you can do, you can skip, there will be written here condition. So we can skip and we can jump to the S6 here. So we can skip and go to S6 here. So by automatically, what is the in the red color mentioned here? So we are wasting the totally 3 clock cycles. And moreover, what you can understand here, the wastage of pipeline as this was never needed here. That's the one. And final drawback with this control set is what? That means it reduces the speed of the pipeline here. So I hope that you understand today what is control hazard and how it arises and disturbing the performance pipeline here. Thank you for watching the video. Thank you.